Hello everyone, welcome to my channel Chemistry is Fun. Today we will deal with types of symmetry in the crystals. Now say, what is a symmetry? Now whenever there is a orderly arrangement of any building constituents like atoms which are found in a crystalline solid, then symmetry will be a fundamental property. In this case, in every arrangement, there will be a certain number of elements of symmetry. That is, if we change the orientation of the arrangement, then the building constituents remain unmoved, means we can say that there is no change in the appearance. Apparently, we do not find any change in the appearance, then we say that it is an element of symmetry, means we are rotating the crystal in such a way that the apparent appearance does not seem to change. That is, the orientation of the arrangement seem to be as it is. There is no change apparently. Now, for any crystal, we find some types of symmetry. First is the center of symmetry. See, we get some similar points. If from the center of the symmetry, which we are saying center of symmetry, if we move equidistant on the opposite sides and we get similar points, then we say that it is the center of symmetry. For example, in this diagram you see, I have drawn this center with a different color. From this point, you move in this direction or you move in this direction. We should cover equidistant distances. The distances should be equal and we get the similar points on both the sides. From here, if you move this side or you move to the other side, again you will get similar points. Then it is called as the center of symmetry, means we get similar points on opposite sides which are equidistant from the center of symmetry. That is, in both the directions if we move, in opposite directions if we move, then it intersects the surface of the crystal and that points will be exactly similar. So it is that point within the crystal such that if we draw any line through it, it will intersect the surface of crystal at equal distances in both the directions. And there is only one center of symmetry. Center of symmetry is only one in number. Next comes plane of symmetry. Plane of symmetry is an imaginary plane. It passes through the center of a crystal in such a way that it divides the crystal in two equal portions and one part is exactly the mirror image of the other. In case of sodium chloride, there are 9 planes of symmetry, among which there are 3 rectangular planes and there are 6 diagonal planes of symmetry. Now see, if we consider the rectangular planes of symmetry, now this is the crystal. If we take in a face, in this face we take the midpoints of the edges and we join them. Same thing we do for the just opposite face. So like this, what you get, this is a rectangular plane of symmetry. This is a rectangular plane of symmetry. So in this you will find that this rectangular plane of symmetry are 3 in number, and if we do it diagonal wise, means opposite diagonals like here to here, if you join, we will get a diagonal plane of symmetry. The diagonal planes of symmetry will be 6 in number, because if you consider this face and this lower face, we can have 2 diagonal planes of symmetry. So for a pair of faces we get 2 diagonal planes of symmetry. So there are 3 such pairs. So 3 2s are 6 diagonal planes of symmetry will be present. Next is axis of symmetry. Axis of symmetry is an imaginary straight line about which, if the crystal is rotated, it will give the same appearance more than once. Means when we are doing the complete revolution about the axis, same type of appearance will come in front of us more than once. If the axis of symmetry is diode, means the appearance will be repeated twice. That is, we start rotating. After a rotation of 180 degree, we come to the same appearance from which we started. Then it is axis of symmetry is diode. If we take the crystal and we start repeating, and after every 120 degree angle we get the similar appearance, means 3 times we are getting the similar appearance, then the axis of symmetry is triad. If after an angle of 90 degree we get the same appearance, means we started rotating about the axis of symmetry, and after a rotation of 90 degree we arrive at the same appearance with which we started. Then after angle of 90 degree we got first time similar appearance. Then again 90 degree means at 180 degree again you get a similar appearance. Like that we are getting the similar appearance 4 times. Then the axis of symmetry is tetrad. Means if we are rotating and at an angle of 360 degree by n, we get the same appearance about the imaginary axis, then it is called as n-fold axis. Like if n equal to 360 degree by n is 120 degree, that is triad, threefold axis. So based on how many times we are getting the same appearance once we start rotating about the axis of symmetry, we can determine what is the value for n in the n-fold axis. So as I told you in my previous video that I will be uploading types of symmetry in crystals. For that I have uploaded this video today. I hope you all could understand whatever I discussed today. Please subscribe to my channel. Thanks for watching my video. Thank you.